So especially on the first day, which was a pretty full day, we did the things, it's in the strand of expressions and operations for which we have strategies. Some may think they're kind of tricks or something that you could use the calculator and actually get these things right. Then we did systems, because I like to think that we could use systems to solve any kind of equation, and we did all that in the day one. In the second day, most of what we did was inequalities, and either one variable inequality, and we showed that there's something to do on a calculator, and a two variable inequality. Yeah, there's something you could do with a calculator with that. But most of the stuff we're going to do from now on, it's not so much with the calculator anyways. It's more of just the plain review of the math. And, some of it I would just consider to be more, I just consider them to be knowledge questions. You either know it or you don't. There's not going to be some clever way to get around the knowing of it. So here we go. And this is just a medium long. We'll probably be done, plenty early. Okay, this is number 27 in your SOL. So you could see this is a question about the range, and there's 4 different functions here to determine the range of. So, it's kind of expected that we know these 4 functions and something about them. So it says, which of the following does not have a range of only the real numbers greater than or equal to 0? Meaning y greater than or equal to 0. So which one doesn't have that range? Okay, let's see. The first one is a square root function. The parent function would it be y equals the square root of x, right? The graph of that would start at 0, 0 of the parent function, and it would go like that into the first quadrant. So looking at the parent function, what is the domain and the range? Right. Okay, the domain, right, the x values, it starts at 0 and it only goes to the right, so you would say the domain is greater than or equal to 0. What is the range? If it starts at 0, 0 and it goes off into the first quadrant. Right. Jake, can pay attention or clowning around? What is the range of this? You should know that instantly, just looking at it. Where does it start? Where does it go? It's greater than or equal to 0, right? It starts at 0, 0. Is 0, 0 on this parent function? If I plug in a 0 for x, then what do I get for y? 0. So yeah, definitely it starts at 0, 0, and it only goes up into positive direction, so that has a range of y greater than or equal to 0. Okay, so now there's some funny things going on with that one right there, because it's 4 minus x. If it was x minus 4, right, if this one was the square root of x minus 4, then what would be the shift? It would be to the right 4, right? And the fact that it's not, that it's 4 minus x, you could consider it to be 2 different things going on. It's negative x minus 4. So it's still shifted to the right, but when you put a minus in front of that, that means that it's actually going to be flipped so that it opens to the left and not to the right. Now the key point for us is there any vertical shift there? So it hasn't moved up or down. Has it been flipped? How do I end up flipping a function? If you had a minus in front, and you don't have that either. So the parent function was y greater than or equal to 0, and this thing will still be y greater than or equal to 0. You could graph it and see what you saw, right? But in fact, this one is still y greater than or equal to 0. Okay, what the second one is absolute value. So what does its parent function look like? It's a v, and so what does, it has a vertex at the origin. What is the domain? I mean, you should know this. If you don't know this, you need to go back and study all these functions. You shouldn't have to memorize. It should make sense. What is the domain? The arrows are pointing infinitely to the left and right. All real numbers. What is the range? Greater than or equal to 0, right? So there we got another greater than or equal to 0. Okay. And x to the fourth, right? If you graphed it, it would look like a flattened, kind of flattened in the middle parabola, right? Would it have the point 0, 0 on it? If I plug in a 0 for x, would I get a 0 for y? Sure. So, I mean, it's going down like that. You know, how many turning points can an x to the fourth have? It could have up to 3 turning points, and this one is only going to have 1. But that's okay. It doesn't have to have 3. It has less than or equal to 3. But again, looking at that graph, there's another range of y greater than or equal to 0. So all 3 of those have ranges of y greater than or equal to 0, which by process of elimination, we can say that the last one doesn't. But you need to know logarithm too, right? And this is the parent function. What's the base of that logarithm? It just says log x, right? There's not a little number there before the x. So what's the base? It's 10. Log base 10. Again, you need to know this. Write it down. Take a note. You got to know this. The logarithm graph has a vertical asymptote on the y-axis, right? That's x equals 0. And it has a x-intercept of 1. And the graph looks something like that. That's not a very good. Let me try that one again. So something like, right, it goes infinitely down. You know, it's getting infinitely close to the x equals 0 without actually touching it. So what is the domain of that function? X is greater than 0, not or equal to, right? Because it cannot touch the y-axis. And the range is all real numbers, right? So definitely this one, I'm trying to think how they do that. In the package, sometimes they'll say this set brackets, the set of all y such that y is a member of, it's like a E, the real numbers, like that. Okay. The logarithm is the inverse of another function that we studied. What was it the inverse of? Exponential. And when you draw it like that, it's the inverse of exponential growth. So, you know, a growth function looks like this. So it has the asymptote on the y-axis, y equals 0. No, on the x-axis, y equals 0. Its domain is all real numbers, and its range is y greater than or equal to 0. So remember that these two, you know, their domains and ranges swap. The domain of one is the range of the other, and vice versa. So in any case, that's it. Now you got to be careful if you depend on the calculator to graph these things, that when you graph a logarithm, let me second plus 712 y equals. You know, if you graph a logarithm, and remember the logarithm is right there, log x. I think you can see it without any kind of shift at all, but notice it looks like it just starts out a little bit less than y equals 0, and it goes up from there. In fact, if I zoom 2, you see a little bit better, but it looks like it stops at that point. It doesn't really stop. You know, it's a little more obvious if I did something like if I shift it. What if I shift it to the right 1/2? Well, I'm going to go in here and say x minus 0.5, just because I'm zoomed in. I want to be able to see it. See how it just is? It's starts in midair like that, that is not real. And you've got to know better than that, you know, especially if you use the calculator to try to see what's going on. It just, the calculator doesn't draw vertical lines, other than that new inequals app does do x equals. But usually it just stops drawing it when it gets close to a vertical line. Okay, so next. That was 27. And there's a lot of information in there, right? You got to recognize in 4 different kinds of functions and knowing domains and ranges. Okay, this is 36. So this is an odd looking graph. The way you get a graph that looks like that, it's y equals, and you use square brackets like this, and that's called a step function or a greatest integer function. And supposedly this is one of the graphs we're familiar with, but we rarely see it at all. But the way you define something like this is the value of y is the value of the integer which is less than or equal to whatever that number is. So, for example, if y equals 0, then, sorry, if x equals 0, you know, what is the integer which is less than or equal to that? 0. So you would have this point right here. I think I'm offset by a little bit, but okay. Now, if I go to, let's say, y equals the greatest integer, which was less than 0.5, it's still 0, right? It's still 0. So it's going to give you a flat line until you get to the next integer. And in this case, look at it, it looks like it's only changing every 2. So actually that graph is probably y equals the square bracket x over 2. And that ought to do the same thing. In your calculator, if you go to math, let me get rid of this, clear. If you go to math num, and the one number 5 says int, that's it. And it just says int with the parentheses, which is not very good. Well, I'll do the 2. Sorry, not 2. So math num 5x divided by 2. And then I'll do a normal zoom. Zoom 6. And you could see the steps. That's why they call it a step function. In our case, we don't really care. I mean, at this point, it's just asking us for the range. So let me get rid of that. What does it look like the set of all the y values involved in these 4 steps are? Right. What about on this segment right there? It's all 1, you know, and on this segment, it's all 2, and on this one, 3, and on this one, 4. That's it. So you would say that the range is 1, 2, 3, 4. Done. Okay, now what would be the domain of this? You should be able to answer that question on the test if they give it to you. Say again. D. No, it's not quite D. What's wrong with it being D? Yeah, this 8, the 8 is actually colored in. That dot's colored in. So it would have to be or equal to. You know, they're very careful, like there's the colored in dot there, but then it's an open dot there. So for every x value, there's a y value, but it's discontinuous. So, what's that? No, this is an open circle on with x equals 0, then it's open circle. So the domain does not include 0, but not on the left. On the right, it includes the 8. Okay, so, okay, next. This is number 44. So this is a rational function. Remember, a rational function is of the form f of x equals, and I think they used p of x divided by q of x. It's one polynomial divided by another. Right? And we did a whole bunch of things with this, all of which we might be asked for. In this case, they're only asking us for a domain. But let's go through the list of all the things that we did. Right? How do you find the zeros of a rational function? What's that? Factor the denominator? No. If a fraction, rational means it's a fraction, right? If a fraction equals 0, which part of the fraction equals 0? The denominator, if the denominator equals 0, it's undefined. The numerator's got to be 0, right? It's when you have 0 divided by a non-zero number, that's what equals 0. So if we want to know what the zeros of a whole rational function is, we got to find the zeros of the numerator. Okay. The next thing we found, when we did this, we kind of did it in an order, right, is how do you find the vertical asymptotes of a rational function? Okay, it's got to be, these are going to be vertical lines, so it has to be x equals the zeros of the denominator. Okay, how do we find the domain? Yeah, you have to say x does not equal the zeros of the denominator. Okay, then the next thing we did was horizontal asymptote. All right, what did the horizontal asymptote depend on? Did you say degree? The degree of the numerator versus the degree of the denominator, okay? So if the degree of the numerator is greater, what's the horizontal asymptote? No horizontal asymptote. If the numerator is a higher power of x than the denominator, right? How about if the degree of the numerator is less? Y equals 0. Remember, it's a horizontal line, so you've got y equals 0. Okay, and then what if it's equal? Y equals the ratio of the coefficient, the leading coefficients of the highest degree terms. Okay, so, and then the last thing that we found, once we knew what the horizontal asymptote was, then we could say, what is the end behavior? So what is the graph doing on the edges of the graph if there's a horizontal asymptote? It's approaching the horizontal asymptote. I mean, that's what a horizontal asymptote is, right? You say, remember, things like this, as x approaches, arrow, plus or minus infinity, y approaches, and I'm just going to write HA. Right, so this one slide, it just asks us for one thing, but all these are legitimate questions that they could ask you, even about this one right here. Now, we want to know the domain, so we're trying to do this thing right here. How do I find the zeros of that denominator? Yeah, I mean, any way you want. I mean, if it helps, you could write a little equation, x squared plus 5x minus 24 equals 0, and then you solve it. If it's factorable, that's probably the easiest way to go. If it's not factorable, what else could you do? Quadratic formula. What else could you do? The app, right? You could do the app. I mean, in this case, you could even use the calculator. You could graph it and look for the x-intercept. So let's see. In this case, I'm just going to factor it, right? This is x plus 8 times x minus 3 equals 0. So what are those? Negative 8 and positive 3. So that would be this one right here. What if the denominator doesn't have any real zeros? Then what are you going to say about the domain? All real numbers. Right? So that's how that works. So a lot of information on that side. Okay, this is number 29. So it says the graph of a parent function is on the left. Which function belongs to the same family? And what it means is that none of these have exactly that graph, right? Because they have numbers that have been added and subtracted and things like that. But again, you should know all of these functions pretty easily. Like this is a logarithm. The parent function of a logarithm we've already looked at, but it goes something like that. Vertical asymptote on the y-axis. What's the effect of the minus in front of the logarithm? It would have flipped it, right? That's a flip. And what's the effect of the minus 1 inside the logarithm? Right. Okay. Well, if I flipped it and moved it to the right one, it still wouldn't look like this, so it's not that. What are the next two? They're both in the same general category. What do you call it when the variable's in the exponent? How about exponential? Okay. You know, I say if you're tired, that's fine. But if you really don't know, you need to be studying this stuff. Not just for your SOL. You can't be staring blankly in math analysis when these things come up. It's supposed to have been better learned than that, right? Which one of these two, B and C, is exponential growth, and which one is decay? B is growth. C is growth because the base is 3, which is greater than 1. And B is decay because 1/3 is less than 1. Okay, they look like both of them have been shifted one to the right, but we know what their graphs look like. You know, one of them looks like this, and one of them looks like this. Right? They have their own horizontal asymptotes that look like that. So neither one of those is right. So we can pretty much say it's not that, and it's not that, and it's not that, so it's got to be this one, right? What do you call that kind of function? How about inverse variation? And if you remember, the parent function, right, the parent function of this one in particular, of the one that's in letter D, would be y equals 3 over x. Right? The 3 is not part of the transformation. It's got to have some number in the numerator. In this case, it's a 3. And because of the -1 in the denominator, then that's been shifted 1 to the right. But the graph, the parent function graph, would have looked like 1 branch in the first quadrant, 1 branch in the third quadrant. So which one of those is in the same family? It's letter D. And you could have just graphed them, right? I think it would have been pretty clear which is the only one that had 2 branches. Okay, next one, 31. Okay, so what kind of function is this? It's an exponential. Is it growth or decay? It's growth. So it looks like the parent function would look like this. Right? It would have a horizontal asymptote of y equals 0. Okay, so what's the effect of this -5 inside the function? Right 5. Right? And about -4 after the function. Down. So which one of those moves the asymptote? The down 4, right? If you take a horizontal line and shift it down 4, you would see it. If you take a horizontal line and move it left or right, you know, it's still in the same place. So it's the down 4, right? If we were to graph it, we would have to say, go 1, 2, 3, 4. And we would draw a new horizontal asymptote. And then it's not just quite that simple because it's actually been moved to the right 5, 2. You know, if I was going to graph it, I would probably take that y-intercept of 1 and I would go down 4, 1, 2, 3, 4, and then I would go to the right 5, 3, 4, 5. And I would know that it should have that point on it. And then the rest of it, you could just sketch in something that generally looks like that. Okay, so what is the equation of this horizontal asymptote? Y equals -4. Right? If you moved it, you took it from y equals 0 and you moved it down 4, now it's at y equals -4. So that's the answer. Okay, next. Another. Here's a logarithm. They like to ask these kinds of function questions with exponentials and logarithms. Again, you should always think of what the function looks like. So you could say, you know, think of the parent function. The parent function of a logarithm, I think we've drawn it about 4 times so far, looks like this. Right? This is x equals 0. Right? Again, what is the effect of -16 inside the function? Right. And what is the effect of a +15 after the function? Up. So which one of those moves the vertical asymptote? The right 16, right? So I would have to go like all the way over here, right? And that can be, I'll say that's 15. So 16 is the next one. And, you know, the graph would be to the right of that. So what is the equation for the asymptote? X equals 16. Now you can't be getting confused about how do I make the equation of a horizontal versus a vertical line. You can see in their 4 answers, that's exactly what they were trying to trap you with. Right? They've got some y equals and they got some x equals. But the way you make a vertical line with the x equals, so it's neither one of those. And again, that +15, if that's moving you up and down, that doesn't change the position of a vertical line. It was the 16 that you needed. So x equals 16. I noticed like on the one before, which, you know, is almost the same problem, but it was with an exponential, they didn't try to trap you with that. They don't have any x equals, they just have the y equals. So that's That's not what they were trying to get you with. Okay, next. Okay, throughout which of the following intervals is this function only decreasing? Okay, so the first thing when we look at that, I mean, ultimately we'll graph this. So we can come up with a fairly good graph without a calculator. What's going to be the degree of that function? What's the highest power of x that's going to come out of that? Well, there's 2 that come out of this x minus 4 squared, but then it's also multiplied times x minus 1. It's a cubic, right? So this is a cubic. We know that for sure. Right, I'm going to put in parentheses, degree equals 3. So we know cubics have a shape that's either like this, or it's like this. Right, which one is this going to have? The one on the left or the one on the right? Left, because this is a positive, right? So it is going to be this one right here. Okay, what are the zeros of this function? What values of x will make f of x equal to 0? 1 and, what's the other one? 4, right? So it's 1, 2, 3, 4. So there's 1 0 goes through the x-axis here, it goes through the x-axis here. Okay, but one of those factors is squared. How does that change the graph when you square that factor? Okay, remember that when the factor is to an odd power, then the graph goes right through it, right? When the factor is from an even powered factor, when the 0 is from an even powered factor, it just touches the 0 and it stays on the same side, right? Because it doesn't change sign. If you're squaring, you know, x minus 4, when you're less than 4, is a negative number, but you square it and it's positive. Right? X minus 4 when you're greater than 4 is a positive number, and when you square it, you're positive. So it stays on the same side. Okay, so that's generally what this one is going to look like. And this just described now. Is it increasing or decreasing on the left side of the graph? What is this piece doing right here? Increasing, and then it's decreasing, and then it's increasing again. Now, my graph is not so great, so I'm going to let's look at the calculator's graph. Y equals clear. And just put it in like that. X minus 1 times x minus 4. And I'm going to zoom 6. Which is pretty much what we've got, right? So now it's giving us these intervals that may not be only decreasing, or maybe some part that's decreasing, but maybe not the whole thing. So remember, the one thing to remember about when you're doing these intervals of increasing and decreasing, they are intervals of x, right? It's only for the x values. So let's see, the x value that starts at negative infinity and goes to 0 is, you know, you could see right from the left side of the graph all the way to the y-axis. What do you think the graph is doing in that interval? And we only see this piece of it, but what is the domain of a cubic? All real numbers. All polynomials are all real numbers. Another one you better write down to know. Okay, what's the most turning points that a cubic can have? 2. And you see both of them on the screen. So you know that this part of the graph, which looks like it goes away, it's really down there, and it's a straight line. There can't be any more turning points in it, right? Because it can only have 2, and they're both on the screen. So what is this function doing to the left of x equals 0? It's going up. It's increasing. increasing, right? This is increasing. Left to right, increasing. So this interval here, negative infinity to 0, that's this right there. So it's increasing, that's not good. Okay, how about negative infinity to 1? What if we increase it so that it's going to that part? Is it only decreasing now? No. I mean, it still looks like it's increasing that whole interval. How about between 1 and 4? Could you say that it's only decreasing there? I mean, the answer is no, because it's increasing and then it's decreasing. Now, if you don't know what you're talking about here, maybe you get confused and say, well, it looks like the function is less than 0 to the left of 1, and then it turns into greater than 0 between 1 and 4. That's not what we're looking at here at all. Okay. Now, the last one has got to be the right answer. It's got to be between 2 and 4 that it's decreasing. You know, in my graph right here, you know, it doesn't look like the top of that graph is right above 2. It looks like it's actually increasing and then decreasing. But if you look at the graph and the calculator, it's kind of hard to see. I mean, in my mind, I wanted to say, is that really where it makes the turning point? Is it right at 2? And the answer is yes, it really is. It's right at 2. And you can find that. It's a procedure that we really haven't used in the calculator much, but if you want to know the maximum point or the minimum point, you know, like most of these things, you go to second trace. And that looks like a maximum point, so I'm going to say 4 for maximum. And then it's going to ask you to give x values, which are to the left and to the right of what you think is the point you're going for. So I'm going to put in 0 for the left, and how about 3 for the right? And then it says guess. Do I want to guess in between those two? Looks pretty good. And mine is giving me 1.999999, so it should be rounded to 2. So yeah, that point, it really starts to decrease right there at 2. Right, so the right answer is 2 to the 4. So make sure you're comfortable with this concept of like increasing and decreasing. You know, what does that mean on the graph? Okay, next. Which number is a 0 of f of x equals log of 4x minus 1? Okay, what does it get? Again, what does it mean to be the 0 of a function? That means that it's an x value you plug in, so the f of x equals 0. Okay, how do you propose we could find that? What do you mean plug it in? Okay, I'm not sure what you mean. Oh, you mean you could back substitute? Yeah, you could in this case. The one thing to keep in mind, if they gave you that same thing and it was not a log base 10, where would you find the log of any base? So you could do that. Right, yeah, if you go to the math button, math, and scroll to the bottom, and there you see log base. Also, you could do alpha window, and it looks like it's number 5. There's one other logarithm function on the calculator. What is it? The ln, right? The natural log. And what's the base of the natural log? E, the irrational number e, right? 2.7182, blah, blah, blah. Keeps going and going. So, I mean, you could graph it. You could back substitute, like Garrison said. You could graph it, right? If I go to y equals, clear. Y equals, clear. Log 4x minus 1. You know, I do a normal zoom. Again, you can see like it cuts it off too abruptly. I can't see very well what's going on there, so I'm going to zoom. Zoom to. So it's in between 0 and 1. So definitely it's not 7/2. It's not 11/4. Does it look like it's more like a half or a fourth? Say again? It looks like it's a half, right? Looks like it's pretty much exactly halfway between the 0 and the 1. Again, remember that the reason why the parent function of logarithms always have an x-intercept of 1 is because the log of any base of 1 equals 0. So if you want to find the zeros, I think probably what they think you're going to do on this problem is you're going to take that 4x minus 1 and you're going to set it equal to 1. You know, what x value is going to make that equal to 1, because then when you take the logarithm, you get 0. And that's a fairly simple algebra, right? 4x equals 2, x equals 2 over 4, which is 1/2. Okay. Next. Okay, which function best represents this graph? Number 32. Well, if you look at the 4 choices, they're all the same kind of function, right? They're all exponential growth. And all of them have one plus or minus inside or after the function. So you're really just judging which one looks like it's got the right shift. How does that one look like it's been shifted? Okay, so Garrison? Down 4. Okay, so the parent function would have had a horizontal asymptote at y equals 0. It would have had a y-intercept of 1, and it would have looked something like that. Okay, so the question is, you know, is that down 3 or is it down 4? And you've got to compare, you know, like the y-intercept to the y-intercept, or the asymptote to the asymptote. I mean, what does it look like the asymptote is on this? It's actually down to -4, right? That's 4, down 4. You know, the most commonly, if we make a mistake with this, because we see the y-intercept of 3, we think right away that it's down 3, but it's not down 3. You know, you got to compare that -3 with +1, so it's down 4. And how do you make a down 4 when you're writing an equation? Which one of those has it? The D. The D. You see, they tried to trick you with the 2 to the x minus 3. Okay, next. All right, the 33. 33. The graph of this function has, and they want to know how many x-intercepts and how many y-intercepts. Okay, so if I compare this function to the parent function, that would have just been log of x. So does multiplying by a number inside the function shift it up or down or left or right? It really doesn't. So we would have expected that this thing has a graph that goes like this, and it doesn't look like we've shifted it vertically or horizontally. I mean, we've changed it a little bit. You know, we've probably made the x-intercept now is going to be 1/2, because 2 times a half is 1, and the log of 1 is 0. But the basic shape is still there. You know, if that were the case, how many x-intercepts and how many y-intercepts do you expect? 1x, 0 y's, okay? So you can always graph it and just look. So y equals clear logarithm of 2x. And I'm zoomed in, but I'll just stay zoomed in. So we see the 1 x-intercept for sure. And, you know, what's going on there that the calculator stops? You know, it's really not stopping. The calculator just can't handle that vertical asymptote. But you could be sure that there is a vertical asymptote there that it's never going to touch, so there's no y-intercept. So none. No y int. So, boom. Okay, identify all the x and y intercepts of this function, number 41. So the most easiest should be the y-intercept. What is the y-intercept? What is the value of x at the y-intercept? Again, something you should know easily. What is the value of x on the y-axis? That's not what I'm asking this moment. I'm saying, what is the value of x on the y-axis? 0. Always, right? If you are on the y-axis, you're not to the right, you're not to the left. That's what x tells you. So you're right in the middle. X equals 0. So if you plugged in a 0 for all three of these x's, then what is the value of the function? -12. Again, should be obvious. It should be, the constant term is always the y-intercept. Always. Because if you put in x equals 0, all those higher degree terms all turn to 0. That's it. So we could say right away, here's the y-intercept. Okay. Now, what's the most number of x-intercepts there could be? 3, right? This is the fundamental theorem of algebra. It says that there can be no more zeros than the degree of the function, and the cubic. Okay, it doesn't mean there are 3, but how could I find the zeros of this function? Can you factor? Maybe. Sometimes, when you have 4 terms, there's one method we never talk about except if there's 4 terms. What method is that? How about grouping? And it's not necessarily going to work. Every time you have 4 terms doesn't mean you can group. But if you notice a pattern, like from the first term, which is a coefficient of 1, to the next term, which is 3, that's like 3 times 1 is 3. Is 3 times -4 -12? Yeah, it is. So in fact, you could group this, right? You would go like this: 0 equals x to the third plus 3x squared, right? Minus parentheses 4x. What goes next? Plus 12. Because you put the parentheses after that minus, it's going to flip the sign. So then you would have to go, this is x squared times x plus 3 minus 4 times x plus 3. Right? So this 0 equals x squared. That was wrong. Oh, no, that's right. X squared minus 4 times x plus 3. But x squared minus 4 can be factored. Right? What are the factors of x squared minus 4? X plus 2 times x minus 2. And we still have the x plus 3. And all that equals 0. So what are the 3 zeros? -2, +2, -3. So where are those as the points? So is it -3, 0, or is it 0, -3? -3, 0, because the y is the thing that's 0 this time. right? So it's negative 3, 0, it's negative 2, 0, and it's positive 2, 0. Now you could also use the app, right? If you want to find the zeros, you'd have to go in like this, apps, 8, 1, but change the order to 3, right? Enter, and next, and now it gives you a place to put in all those coefficients. 1, that is a plus. 3, the next one is a minus. 4, next one is a minus. 12, and solve. Negative 3, negative 2, 0, or 2. Okay, so you got a lot of options there. Okay, next. We're almost done. Okay, which of the following describes the end behavior of that function as x approaches either positive or negative infinity? Well, what kind of a function is that? Based on the highest degree term, what do you call that? Say again? Quadratic, right? Quadratic. And does it open up or down? Down because of that right there. So we know this is a quadratic. That in one way or the other, we don't really know much else because they've got B and C as constants, but we don't know it. We don't know enough. All we really know that the shape does something like that, right? A parabola that opens down. Okay, so what is the function doing as you go to the right towards positive infinity? It's going down, right, towards negative infinity. What's the function doing as you go to the left towards negative infinity? It's also going down, right? So the right answer would be, as x approaches positive or negative infinity, this graph is approaching negative infinity. So remember, this one there was a quadratic. But if this had been y equals negative x to the fourth plus bx plus c, because it's also an even degree polynomial, it would have been exactly the same answer. If it was x to the 6th or x to the 8th or x to the 10th, any even degree polynomial would have the same behavior, given that there's a negative in front of it there, right? And all the odd degree polynomials have their own, right? Easiest to see if you look at cubic, right? So a cubic, wouldn't have the same end behavior on the right or the left, right? If it was like y equals negative x to the third plus bx squared plus cx plus d, right? Then it would be this one right here. And you would have to say, as x approaches positive infinity, the graph is going down towards negative infinity. As x approaches negative infinity, the graph goes up. And it doesn't matter really if that's a 3 or a 5 or a 7, if it's any odd degree, that's the way it works. Okay, next. Right, which graph best represents a function that has zeros of negative 2, negative 1, and positive 2? This is really an algebra 1 question, but I don't know. It's in there. Right? Well, that's 3 zeros. How many zeros do A and C have? They just have 2, right? 1 and 2. 1 and 2. So it can't be either one of those. So which one of these has exactly negative 2, negative 1, and positive 2? D, right there. So what you don't want to get confused on this is, it is true that if we were going to have this function written out, it would be like this: y equals x plus 2, x plus 1. I said plus 1 and I did the opposite. X plus 1 and x minus 2. You know, it kind of has an opposite sense. And if you were looking at these here thinking, oh, does that mean that I'm actually looking for +2 and +1 and -2? No, it doesn't. Okay. I mean, if it did, that's why they've got that letter B there for people that are going to try to make that. Okay. So that's the relationship between zeros and linear factors. So that's it. I'm going to clean that up and give it to you here, because I already did. Just take me a second. Oh, I guess I didn't, because I deleted that. I've already typed it in here. Okay, so it should be page 7, number 8, and page 21, number 5. They really came from what we did last class or earlier, but I somehow didn't assign these two. And then the rest come from this 27. Well, that was wrong. 34. Oops. That's it. And they're not hard. It probably won't take you that much time.